Hello guys, welcome back to mathematics. To my learners and followers, I welcome you back to the lesson of mathematics. So today we are going to look at the area of a sector. My name is Joel Mudui, a teacher of mathematics. Welcome and further the lesson up to the last minute. So we are looking at a sector, and a sector uh, it is part of a circle which is bounded by two radii and an arc. So we are going to demonstrate and say if you have a circle like that, and now this is the center, then you have a radii and a radii. You can name this as R, and this is an R, and we have an angle which is subtended at the center. You call it theta. So this part, which is bounded by two radii and an arc, this is an arc. An arc is part of the circumference. Then this one you can call it a sector. Now, if you have two radii, then you are going to have this as minor sector and this upper part as the major sector. So, if now we can try to divide a sector, we can say now a sector is part of a circle which is now bounded by two radii. These are the two radii and an arc. This is the arc from here to here. I have said that the arc is the part of the circumference. Then the angle subtended at the center is known as theta. It is known as the theta. Now, as we look at the sector, you'll realize that if we want the area of the sector, you'll realize that this is part of the circle and this is the part of the circle. Now, if we want the fraction of the area of the circle here, you know the angles at a point that up to 360. 360. So if we want the fraction which is bounded by this sector, then we will say it is this angle over 360. So we will start by saying, but we know that the area, of a circle is given by pi r squared. If it is given by pi r squared, then you will realize that the fraction of the sector will be given by the angle subtended at the center, which is theta, over the total angles at a point, which is 360. Now, if you want the area of the sector now, the area of the sector, it will be given by the fraction, which is theta, over 360 multiplied by the area of a circle, which is pi r squared. So the area of a sector is given by theta over 360 pi r squared. Theta is the angle subtended at the center. 360 is the total angles. Pi is always given by, you can say pi is given by 22 over 7. Sometimes if you take a calculator and try to get the pi, you can say it's just 22 divided by 7, and you will get 3.142. If you write that one correct to three significant figures, or just three significant figures, you will realize that 3 is the first, then we have 1, 4, 2. Sometimes you can be told to take pi as 3.142. They are all the same thing. So now the area of a sector is given by theta over 360 pi r squared. And you can see the sector, the two sectors have been given here. So if you are given this angle and you want the other angle, you can simply subtract this one from 360 degrees. So my learners, my followers, that is how you calculate the area of a sector, the area of a sector. Now, up to this point, we are going to solve some three examples about the area of a sector. Then we will get to understand very well for now to calculate the area of a sector. Now look at that question, our first example. We can read and say, find the area of the sector below. Let's look at that sector. It has a radius of 14 and the angle subtended at the center is 120. We said a sector is area bounded by the two radii and an arc. Remember what we said about the area. So we said that the area of a sector is given by the angle, which is theta, over 360, then multiply now by the area of a circle. So the formula is theta over 360 pi r squared. Theta over 360 pi r squared. Now, according to our formula, we can just write and say the area will be given by, what is our theta? Our theta is 120 degrees. So you say 120 degrees over 360. Then multiply by our pi. Pi is always 22 over 7. Then now times the radius, which is 14 squared. We can rewrite again very well and say the area will be given by what? 120 over 360 multiplied by what? 22 over 7, which is our pi, times radius squared. You can just say it is 14 times 14. Now we have replaced, or we have substituted everything which is on the formula. Now, up to this point now, we can just simplify. Let's simplify. Here, 0 goes with 0. Then you can realize that 12 can go to 36 by 12 you can get 1, and by 12 you get what? 3. Now let's look at 7 and 14. You can see 7 goes to 14 2 times, so you can say by 7 1 and by 7 2. If you look at the numerators and the denominators, we cannot simplify any further. This method I was using, it is called simplification. So if there is nothing we can simplify further, we can now multiply the numerators and say this is 1 times 22. You just get 22. Then now 22 times 2 times 14. Then over 3 times 1 is just 3. Now can we multiply the numerators? You will say it is 22 times 2 times 14. 22 times 2 times 14. We can multiply that one using a calculator. You'll get 616. Get 616 all over the 3. Now, we can simplify further and get the answer 600. Can key in 616, you divide by 3. And now get the answer as 205.3 centimeter squared. So our answer is what? 205.33 centimeter squared. Let's look at what we have done. We started with the sector, and we said the formula is theta over 360 pi r squared. Theta over 360 pi r squared. And we said that we have our radius as 14 and our theta as 120. And we tried to replace this one in our question. Then we simplified. Then now we picked the numerators which were unable to be simplified, and we said here we have 22 times 2 times 14. Then on the denominator we end only 3. And now through simplification you will realize that we have 616 divided by 3 and you get 205.33 centimeter square. Remember 3 is recurring, so you can just write it correct to at least 4 to 5 significant fingers. So we have 1, 2, 3, 4, 5, or at least 2 to 3 decimal places. They will make you a little bit safe, so that your answer does not have premature rounding off. Let's look at the second example. Now, second example, we have a sector's radius of 84 centimeters, and the angle which is subtended at the center is 60. And now we are supposed to find this area. Now, remember, we said the area of our sector is given by what? Theta over 360, then now pi r squared. Theta over 360 pi r squared. Now we can pick whatever is in the question and substitute it in the formula, and we'll say the area is given by, start with theta. Theta is the angle subtended at the center. So our theta is 60. You divide it by 360 to give you the fraction of the sector. Then you multiply by the pi. Pi is, if you are not given, you can comfortably use 22 over 7. Then now multiply it by The radius is 84. So you can just say it is 84 and a multiply by 84. Remember what is a square? A square is multiply the number by itself. So here radius is squared. So if it is 84, you multiply 84 by 84. Let's look at the question, whatever we have substituted. Do you see that there's something that we can simplify? Yes, we can simplify. Simplification, you just compare the numerator and the denominator and see whether you have any multiple which can really divide numerator with the denominator. So starting, we will start with this one. The 0 can cancel out with the 0. Then you can see that 6 and 6, it's the multiple. So you can say by 6, 1, and by 6, 6. Looking at 84 and 7, you always feel free to use a calculator to see whether 84 can be divided by 7. So you have 84 divided by 7. You can see it is 12. So you can say by 7, 1 by 7, 12. Then you can see here you have 6 and here we have 12. 6 goes to 12 how many times? 2. So you have 2 there. Then now you can see we do not have anything on the denominator. So we comfortably multiply the numerators. So we have 22 times 2 times 84. And our area, so I've said we have 22 times 2 times 84, whatever is in the numerator. The denominator we have 1 and 1. And anything divided by 1, you just get the numerator. So let's multiply here. Feel free to use the calculator. You have 22 times 2 times what? 84. And now you can simply click the answer and get what? 3,696 centimeter what? Squared. So the area of this sector with the angle subtended at the center as 60 and the radius as 84 using the formula of theta over 360 pi r squared. After simplification, you will get what? 3,696 centimeter what? Squared, because this is area. This is area and the area is calculated like that. Now, if you have any question about the same, you can just comment down there and ask the question, then I will answer you accordingly. Now, as we move on, we want to attempt the third example about the area of a sector. The area of a sector. And now we are looking at this. Let's look at that question. What does the question say? The area of a sector is 64 centimeter squared. Find the angle subtended at the center, and the angle has been given as theta. So as we look at this sector, let's look at it. What do we have? We have been given the area. We know the area. The formula for finding the area of a sector is theta over 360 pi r squared. On the question, what have we been given? We have been given the area as what? 64 centimeter squared. We have been given the area 64 centimeters squared. We have been given the radius as 7 centimeters. And now we have to find theta, which is the angle subtended at the center. So after analyzing like that, we always replace what we have to the formula and now we find what we do not have. So we have the area. So the area is 64. So on your question, we are going to substitute the area 64 centimeter squared is equal to theta. We do not have, so we will write just theta over what? 360. Multiplied by pi. Pi we know is what? 22 over 7. Then you multiply by what? The radius, which is 7. So you say times 7 times 7. So on this, on the right hand side, you can see whatever you can simplify to have the simplest form. So you can see this 7 can go with that 7 to have 1. Then here, you can just say you will multiply the numerators, then equate them. So here we have theta times 22 times 7. So theta is an unknown, so we just multiply the numerator that are known, which we have 22 times 7, get 154. So you'll see 154 theta over 360 is equals to what? 64 centimeter square. Now look at this. If you have this kind of a scenario, you just need to remain with the theta here. So you multiply by the reciprocal of the coefficient of theta. So coefficient of theta is 154 over 360. So you multiply by the reciprocal of 154 over 360, both sides, on this side and on the other side of the equal sign. So the reciprocal of 154 over 360 is what? You just interchange the numerator with the denominator. And now you will say multiply by what? 360 of 154. Whatever you do on this side, you also do it on this side. So you multiply by what? 360 over 154. So you realize that this 360 and that 360 goes. 54 and 50 goes. So you remain with what? Theta. Remain with theta. So let's simplify on the left side of our question. You can just use a calculator and can simply say it is, and just open the bracket and saying 360. You multiply it by what? 64. Then you can divide by what? The denominator is 154. And you click the answer. So the answer gives you what? 149.6. So we'll say 149.6 degrees. That is our theta. You can see here 360 times 64 divided by 154. Get 149.6 degrees. So this was a somewhat reverse where we were supposed to get the angle theta when you are given the area and the radius. So guys, that's how you find out when it is reversed. Just write the formula, substitute what you have in the formula. Then when you have already substituted, now you can simplify and find out what you do not have. Like we have said here, we have seen this substitution here, and immediately when you have somewhere where you only want to remain with the unknown, you simply multiply by the reciprocal to remain with theta on one side. I know some of you might ask, why is it this theta was here and now it has started here? There's no issue with that. You can just start with the theta is equals to this, or you can say 149.6 it is equals to what? The theta we were looking at. Now, at this point, I want to thank you for following my lessons. Remember to comment, subscribe, and like my YouTube channel. I'm also on TikTok, Facebook, and Instagram at Dr. Joel CV. Please do support me. Make sure you watch the other videos I've already taught, and God will bless you. Have a blessed time.